Welcome to today's math lesson. If you will make your way to Schoology, there is an activity for October 27th. It's your second lesson in volume. Yesterday's lesson was October 25th, and in that lesson, it was a review of what you covered as far as volume of rectangular prisms when you learned about that in 5th grade. So that was a review of your volume skills. I do need you to make sure that you do go back to the 25th and make sure you hit submit. I think I had only 3 or 4 students from each class that actually turned in their assignment from yesterday, so just go back and make sure before you start today's that you did turn in yesterday's assignment. But today is October the 26th, and we are going to be looking at volume again. Remember when we work with assignments on Schoology that we do open them with Kami? All right. So when working with Kami, remember you can draw, add text boxes, equations, all kinds of things that you can do with Kami. So our 6th grade standard says that we are going to be able to find the volume of a right rectangular prism. We talked about yesterday how that is a 3-dimensional object. And we need to specifically be able to do that with fractional side lengths. So with fractions as the lengths on our sides. Yesterday you worked with whole numbers again as a review of this skill. So you need to be able to do this with unit cubes as well as with your volume formulas. And your volume formulas are included there in the standard. And it even tells you that B is the area of the base. So we have length times width times height, or you could think of it as the area of the base times your height. So remember, when we're talking about volume, we're talking about the space that an object occupies or takes up. So this is packing with unit cubes. Mr. Wrangle was putting away ornaments from his Christmas tree. Each individual ornament is secured in a box, and then all the ornaments are placed in a larger storage tub. Discuss the different ways that Mr. Wrangle can determine if the ornaments will fit in the tub. So, each individual ornament is secured in a box, and then all the ornaments are placed in a larger storage tub. Use the images below to label the dimensions with the number of cubes in each rectangular prism, then count the volume of unit cubes. So this little cube has a side length of 1 unit. So this is 1. Every side is 1. So if we did the volume of just this one little cube, it would be 1 unit cubed. So what they want you to do is, it says to label the dimensions with the number of cubes in each rectangular prism. So this is a rectangular prism, this is a rectangular prism, and you need to count up the cubes for the dimensions. So if we're talking about our length, there are 1, 2, 3, 4 cubes in the length. If we're talking about the width, 1, 2, 3, 4 again. And then when we are talking about the height, that's right here, it is 1 cube in height. And it says, then count the volume of unit cubes. So if we have 4, and we have 4 rows of 4, we would have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. We only have one row of that, so our volume here is 16 cubic units or units cubed. And that is a 3. That looks like a backwards C, but that is then we look over at our next rectangular prism, and we see that we have a width of 2. We have a length of 4. And then we have a height of 2. So if we count those up, that is 1, 2, 3, 4 rows of 2. So that would be 2, 4, 6, 8. And we have that twice. So 8 plus 8 more would be 16. And we would find the same thing if we multiplied here. 2 times 4 is 8. 8 times 2 is 16. So again, we can count our cubes. We can use our formula. Length times width times height. Alright, number 2. Use the image below to label the dimensions with the number of cubes in each rectangular prism, then count the volume of unit cubes. So we have a unit cube here. However, this time the side length is 1/2. So we have every side, our length, width, height, all of it is 1/2. So we have a half, a half, a half, and a half. So if we're looking at this, our length, we have 4 cubes, but they're each a half. So that would be 4 halves for our length. Then we have our width, same, there's 4 again, but these are half units. So we have 4 halves. And then our height, we have 1. Again, remember we're dealing with half. So we have 1/2. So to find the volume, we would be multiplying 4 halves times 4 halves times 1/2. So we have 4 times 4 is 16 times 1 is 16. And then we have 2 times 2 is 4 times 2 more. 4 times 2 would be 8. Remember that fractions are division, so we can divide 16 divided by 8. That is a basic fact. So 8 times 2 is 16. So our volume is 2 units cubed. Alright, so that's how we use our fractional side lengths. So it's the same as before, but we have changed things up a little bit. With this, when we're looking at our units, we just want to make sure that we don't count each box as 1, but we count it as whatever our fraction is. So let's take a look at our second one here. We have, again, we're still dealing with half units, so we have a width. There's 2 cubes, but each cube is 1/2. So we have 2 halves, or we could think of it as 1. I would leave these as fractions until you're done multiplying, and then I would either divide or simplify, whichever needs to be done with these. Then we have our length, There are 4. However, again, we're dealing with halves, so we have 4 halves. And then we have a height of 2. And we're dealing with halves, so we have 2 halves. Now we multiply length times width times height. 4 halves times 2 halves times 2 halves. 4 times 2 is 8. 8 times 2 is 16. 2 times 2 is 4. 4 times 2 is 8. And again, fractions are divisions, so 16 divided by 8 is going to be 2 units cubed. Alright, let's take a look at the next problem. For number 3, it says, Mrs. Sebastian asked students to estimate how many cubes could be packed into the rectangular prism shown below. What process should her students take in order to find the solution? How could you mathematically determine if your estimate is correct or not? So, here is the small unit cube. They are to estimate how many cubes can be packed into this rectangular prism. So, this is really one for you to think on for yourself, to determine what you think the process should be in order for them to find their estimate, and then how could they determine mathematically if their estimate is correct or not. So think about what you know about volume and how we take these little unit cubes and we pack them in to rectangular prisms. Like here, these have unit cubes packed inside of them, right? So think about that process and how you would determine how many of these little cubes would go into this prism. So this is not a question I'm going to go over with you. I want you to answer that one on your own. All right, packing with unit cubes. It says first determine the blank of both the smaller prism and the larger prism. And then it says then divide the volume of the blank prism by the volume of the small prism. So, we're going to take a look at some other problems and we'll come back to those fill in the blanks. All right. Actually, no, let's go ahead and talk about it. So first determine the volumes or volume of both prisms, so the smaller and the larger, then divide the volume divide the larger prism by the volume of the smaller prism. Sorry. Divide the volume of the large prism by the volume. And that's really sloppy here. Let's see if I can write that a little more. Divide the volume of the large prism by the volume of the small prism. So if you're ever given 2 different prisms to figure out the volume of, and they want you to see how many of the smaller might fit into the larger, then you want to do exactly those 2 steps. So if you're trying to determine how many of a smaller prism can go into a larger prism. Then, again, you want to find the volume of each and then divide the larger by the smaller. So, let's take a look at actually doing that with some problems. So number 4, it says determine how many cubes it will take to fill the rectangular prism below. So if you notice, this is the same thing that you had to do up here, figure out how you could estimate that. So this would be the process here where we went over packing with cubes, this little section here, find the volume of each, and then divide the larger by the smaller. That would be the process behind it. And number 4 is actually a problem where we are putting that into practice. So determine how many cubes it will take to fill the rectangular prism below. We have a unit cube that is 1/2 by 1/2 by 1/2, right? So that is 1/2 by 1/2 by 1/2. So if we multiply all of that, 1 times 1 is 1 times 1 is 1. 2 times 2 is 4. 4 times 2 is 8. So the volume of the small one is 1/8. Then we have to find the volume of the larger prism. So we have length times width times height. So we have 5/2 times 1/2 times 3/2. So we want to find this volume. So we found the volume of the small one. Now we're going to find the volume of the larger one. 5 times 1 is 5. 5 times 3 is 15. Then we have 2 times 2 is 4. Times 2 is 8. So we have 15/8. And I would not change that yet. I would first figure out how many it's going to take to fill up the box first. So what we did here, that's your steps here. The part I skipped over was writing the formula length times width times height, and then those are the values that you would plug in. It's hard to write small on this. 1/2 times 1/2 times 1/2 for a volume of 1/8. And then the same thing over here. Formula length times width times height. And then 5/2 times 1/2 times 3/2. That's really sloppy. Sorry. Is 15/8. Alright, so we have the volume of the smaller and the volume of the larger. Once we have that, if we remember our process from above, then we are going to take the larger, 15/8, and divide that by the volume of our smaller, which would be 1/8. Then, this is one of the reasons why I told you to leave them as fractions, even improper fractions, until you're completely done with all of your operations. Because if you hadn't, then this would have become a mixed number and you would have had to change it back to an improper fraction anyways. So leave them until you're done. So 15/8 divided by 1/8, we want to keep the first fraction, change the division to multiplication, and then find the reciprocal of our second fraction. So that's 8/1. Now you're going to multiply 15 times 8 and then 8 times 1 and get an answer and then divide. Or you can go ahead and simplify here. 8 divided by 8 is 1. So your answer here is going to be 15/1 or 15. So, 15 cubes, 15 of the small cubes can fit in the larger rectangular prism here. And you might have known that if you have 1/8, if each little one is 1/8, and you need a total of 15/8, you probably could have done that in your head without actually dividing it. But just to get the process and the steps down, it's good that we went ahead and did this. So let's take a look at the next problem. Number 5 says determine how many cubes it will take to fill the rectangular prism below. So first, find the volume of each. And I want you to do some of this on your own before we actually go over it. So find the volume of the small and then of the large. So pause the video and do that on your own, please. Okay, so if we're finding the volume of the small, we have our formula, length times width times height, right? So we have 1/3 times 1/3, because all the sides are 1/3 on the small cube, times 1/3. All right, so through 1 times 1 times 1, that's going to be 1. 3 times 3 is 9, times 3 more is going to be 27. So we have 1/27. Then we have our second rectangular prism. Length times width times height. So we want to do that one next. We want to do 4/3 times 3/3 times 2/3. So we want to do 4 times 3, that would be 12. 12 times 2 would be 24. And then we have the same as what we had over in our first one. We have 3 times 3 is 9. 9 times 3 is 27. Then we want to divide. We want to take our larger one, 24/27, and we want to divide that by the smaller one, which is 1/27. We keep 24/27, change division to multiplication, and then flip 27/1. If we have 24 times 27 on the top, and then we have 27 times 1 on the bottom, then we can go ahead and cancel these out. 27 divided by 27 is going to give you 1. So we have 24/1. So we have 24. So 24 small unit cubes can go inside of the rectangular prism. The rest of this I would like for you to complete on your own. So you are going to finish the rest of this on your own. It says 3 students are given different size rectangular prisms and the same size unit cube. Use the key at the right to determine how many cubes will fill each of the rectangular prisms below. So this is the unit cube that they are given. So you'll find the volume of that one. Then you're going to be finding the volume of each student's rectangular prism by following the same steps that we did with the previous problems: formula, values, volume. Okay. Then you're going to take whatever the volume is here of Jonah's larger rectangular prism and divide it by your unit cube volume. And then the same for each of the students. Then you'll do Reese and then Alonzo. So complete those three problems on your own. Make sure that you click this nice little turn in option up here on your screen. If you do not click that, I don't get your work. So please, please, please make sure that you turn it in. If you weren't sure what I was talking about earlier when I asked you to turn in yesterday's, if you will please go back and make sure that you have clicked turn in, because I have not received yesterday's assignment from most of my students. If you have any questions, please message me, and hopefully I will be back at school tomorrow.